Hello there. Let's wrap up chapter 12, the first part of chapter 12 that we're learning here about chi-squared. We're going to finish up just talking about which test is which, and then I have one additional thing to consider when dealing with chi-square tests. All right. So, which test do we use? We've learned a chi-squared test for goodness of fit test, test for independence, and test for homogeneity, and they're all very similar in how you conduct them, but they're different in what they are and what they're looking for. So a goodness of fit test is from one sample, and it typically has one categorical variable. We're just comparing the observed to the expected values. Okay? Whereas a test for independence also comes from one sample, but it has two categorical variables that we're trying to decide if they are associated in some way or not. And then the third one, test for homogeneity, has two or more samples or an experiment with one categorical variable each. Okay? Now, that's the main difference. So I would say don't rely just on seeing the term association or relationship because it's not always going to be a test for independence. It oftentimes is, but not always. So it's important to check how the data was collected. Was there one sample? Was there two or more samples or an experiment? That kind of would decide between those two. Because otherwise, tests for independence and homogeneity, a lot of things look the same. It's coming from two-way tables and just a lot of similarities. So let's look at a few of these. And I want you to determine which test we're going to use. So it might help to pause and think about it before I give the answer. So this one says, are men and women equally likely to suffer lingering fear from watching scary movies as children? Researchers asked a random sample of 117 college students to write narrative accounts of their exposure to scary movies before the age of 13. More than one-fourth of the students said that some of the fright symptoms are still present when they're awake. The following table breaks down these gender results. So we got male and female, yes or no on the fright symptoms. So what type of test is this? Well, this one's going to be a chi-square test for independence. So it states that we have a random sample, so one sample, but we're comparing two different things, the gender and the fright symptoms within that sample. It's not a separate sample of males and females, it is just one sample. And so this is a test for independence. Let's go on the second one. Which test? So cocaine addicts need cocaine to feel any pleasure, so perhaps giving them an antidepressant drug will help. A 3-year study with 72 chronic cocaine users compared an antidepressant drug called desipramine with lithium, a standard drug to treat cocaine addiction, and a placebo. 1/3 of the subjects were randomly assigned to each treatment. Okay? Now, you might be thinking, I've got relapse or no, so that's a variable, and then 3 different drugs. Now, the way it's given, this is an experiment where they're going to be divvied up to the 3 different drugs administered. So it's not it's not just a different variable, it is actually 3 different groups. So we have multiple samples or we have an experiment. This is a test for homogeneity. All right, example number 3. What's the most important reason that students buy from catalogs? The answer may differ for different groups of students. Here are results from separate random samples of American and Asian students at a large Midwestern university. Is there an association between the catalog, shopping attitudes, and race? There's the data. Now again, we've got 2 different random samples, which means it's got to be homogeneity, right? But it says association. Does that mean it has to be a test for independence? Look at how it's done. This is 2 different samples, so this is also a test for homogeneity. Not a test for independence, even though it used that word association. All right, Number 4, casinos are required to verify that their games operate as advertised. American roulette wheels have 38 slots, 18 red, 18 black, and 2 green. And when casino managers record data from a random sample of 200 spins of one of their American roulette wheels. Okay, taking 200 spins from one wheel. There's your random sample, and there's your data. We're testing to see if they are properly calibrated so that we're getting the correct amount as advertised. That is just comparing expected to observed, one sample, one variable. This is a test, goodness of fit test. The last one I have here. In his book, Outliers, Malcolm Gladwell suggests a hockey player's birth month as a big influence on his chance to make it big in the highest level of the game. Specifically because January 1st is the cutoff date for youth leagues in Canada, where many National Hockey League players come from. Players born in January will be competing against players up to 12 months younger, or close to that, one day less than that. The older players tend to be bigger, stronger, and more coordinated, and hence get more playing time, more coaching, and have a better chance to be successful. So to see if the birth date is related to success, which is judged by whether a player can make it into the NHL, a random sample of 80 NHL players was selected, and they looked at their birthdays. So if you looked at their birthdays, 32 of the 80 came from January to March, 20 came from April to June, and then it's just getting smaller and smaller there. So it seems like there might be some evidence there. We'd have to test it, but we have one sample of 80 players, and the only variable is birthday. We're just seeing how far off it is from the expected, and that is, again, a goodness of fit test. So again, think about how it's set up, especially with the independence versus homogeneity, because those are set up the same way. They have the two-way tables usually. So we have to look at how the sampling has been done. So I want to look at one other thing here, and it has to do with it, like this example. I have we're comparing. Well, it says, do veterinarians in Waukesha County treat the same type of animals that vets in Waukesha County, or Washington County do? So a random sample of 5 vets in each of the counties yielded the following data concerning the number of animals that were treated given them in a given morning in March. Test the appropriate hypothesis using yada, yada, yada. Okay, so this is the data that's given. A lot of dogs and cats, not very many horses or others. So those are the 4 categories that were given. Now, if you were to do this, and you would find each individual expected counts, because we need to find those, what's the problem here? This is the problem. 4 of them are less than 5. Which is a sad face, because that definitely is not meeting our condition for large counts for a chi-square test. So what can you do if that's the issue? So you can change how you set things up. And it's called collapsing categories. Okay? So if I see that horses is its own category, but they're really not that many, and there's an others category, we could combine those, collapse them to be just all others, or we could say horses and others, but it's really just others. Then we have higher amounts, and then if we check our expected counts, they're actually not all met, but one of them is close. The rest are all met. So I would say that's a lot better. It's not perfect, but it's better. And I would at least say proceed with caution. So collapsing columns is something that you can do when dealing with some sort of a hypothesis test that deals with chi-squared. Now, one last thing I want to touch on. Sometimes we have questions that compare proportions. Oftentimes you think it's a 2-sample proportion, or like 2 proportion is a 2-portion z-test. And usually that is totally fine. But if it has a a test that we're looking at and not equal, a two-way test, a two-tailed test, you can also use a chi-square test for homogeneity. Like if I took this and I did a chi-square test for homogeneity, my hypothesis would be the distribution of customer genders secondhand shopping is the same for the two cities. We're looking at city 1 and city 2 versus different. If it's a true proportion, we're saying the true proportion of male shoppers would be the same or different, essentially, would be our hypotheses, which is very similar. Now, if we did our test, we've got some data, some stuff here. We get a p-value, chi-squared of 15.33, p-value is about 9, this 0.0000901-ish. If we did it with a two proportion, guess what? This is 0.0000901-ish. They are almost identical using two different distributions. And that's if we're looking at a chi-square test for homogeneity, only working with a 2x2 two-way table, and only looking at a hypothesis that's two-sided. Those can match up very directly. We can't use chi-square test for a one-sided test, however, okay, when we're dealing with these proportions. So those are just a couple of the things that we want to consider when we're dealing with chi-squared, other than the tests themselves. So that's section 12 2C. That's it for chi-square. See you next time.